Hello, my students. Welcome to the lesson 4.5, which is the solution to quadratic equations by the method of the general quadratic formula. Okay, I'm pretty sure that you already know this formula and you know how it works. I'm 99% sure that 99% of you know how to do this already. But formally speaking, I need to go over the lesson, and maybe I'm gonna dispel some confusions about how this formula works and where it comes from. Okay, so I hope this is a very quick lesson. So let's start. Let's read this sentence. If we have a quadratic equation in standard form, and I remind you what the standard form means, it means exactly this, then we can get its two solutions with the formula, this one. Okay, this is what we understand as the general quadratic formula. Some people just call it the general formula. Some people just call it the quadratic formula. And that's fine. We more or less understand what that means. But technically speaking, we have to say the whole thing. General quadratic formula. And it's all of this, okay? So what is B and A and C in this formula? They stand for your coefficients, okay? The coefficients of each of these terms. Remember, you have three terms in a quadratic formula. You have the quadratic term with its proper coefficient that is usually called A, and then the linear term with its coefficient, which is usually called B, and then maybe I should look. The term also consists of its proper sign. Okay, so this is the sign of this term, and then the other term, which is the constant term, is this one, and it's represented usually by the letter C. Does that mean that it always has to look like this? I mean, what if I write this? Dx squared plus ex plus f equals 0. Does this have the same shape as this? Of course. It's the same, okay? Can you see? This formula doesn't have to appear always with A, B, or C. You have to understand that, okay? I can write this. This is perfectly okay. This is also representing a quadratic equation in standard form. And if I have this formula, then the respective changes would be this. X equals minus E plus minus e to the square minus 4 times df, the square root of all of this, over 2d. Okay? It would be exactly the same. Okay? So don't get married to the idea that it's always have to be a, b, and c. It can be any variable. It doesn't matter. Any symbol representing those coefficients. Okay. Now, where does this formula come from? If you remember, guys, we already saw the method of completing the perfect square trinomial. Now, in second semester, that is next semester, I'm going to show you how, by starting with this equation, which is a quadratic equation in general form, I'm not talking about any specific A, B, or C. This is a general quadratic equation, okay? I'm not giving you any particular example, for example, like this. This is a particular example of a quadratic equation. This is a general, an abstract quadratic equation. Now, if you take this equation in general form and in standard form, and you start to apply the process of completing the perfect square trinomial, you remember, you make sure that the first the coefficient of the x squared is 1. And how do you do that? Well, we divide everything by that coefficient. Can you remember that? And then we do this and blah blah blah, many steps. Okay, when you start doing that process for this particular equation, what you end up with is in fact that formula. Okay, so I need you to understand this. This new method, this apparently new method of solving a quadratic equation is not really new. It's not really new. It's basically the method of completing the square trinomial, completing the square, but applied to a general quadratic formula. You see, you can understand this perfectly in second semester. You're gonna understand where this comes from scratch. Like you are actually gonna be able to deduce this on your own in second semester. I guarantee that to you. Okay, but I'm gonna wait for that until second semester. Okay, so in the meantime, you just know that this is the way it works. This is how the formula works, and just basically know how to use it. That's it. Remember, there is a big difference between using a formula and understanding why that formula is the way it is. Okay, so let's put this formula to use with some quick examples. So let's start with example 1. What about if we have the following formula? I'm sorry, the following equation. Is this a quadratic equation? Yes. Is it in standard form? No. So let me put it in standard form. That's the first thing you have to do. Put the formula in, put the equation in standard form. There you have it. Okay? This is the same equation, but in standard form. Now, all you have to do is identify the coefficients of each of your terms. This is the quadratic term. Its coefficient is 1, even though we don't write it. This is the linear term. Its coefficient is plus 2. And this is the constant term, and its coefficient is minus 3. So basically, we have found the values of our A, B, and C, which is 1, 2, and minus 3. And that's it, guys. That's it. Once you have obtained these three coefficients, the rest is just a boring substitution, okay? It's very basic. All you need to do is remember the quadratic formula, write it down. By the way, yes, you have to memorize this formula, okay? It's one of the few formulas that you have to memorize in high school. So memorize it. So there you have it. And all you need to do next is just substitute these values in here with a lot of care. With a lot of care. My suggestion is do it in this way, the way I'm doing it, with parentheses. Can you see what I'm doing? I'm introducing every single coefficient with parentheses in this way. Sorry about that noise. That's my neighbor. So, well, let me stop the lesson for a moment. Sorry about that, guys. Maybe I'm gonna need to do that a few more times. I don't know what my neighbor is doing. Okay, so then we have this. Okay, and basically you are finished, guys. All you need to do now is just this looks complex. I understand because it's a lot of numbers and a lot of signs and so on. So all you need to do next is basically do this arithmetic as well as you can. Okay, 2 to the square is 4, and then minus all of this number, which is a multiplication. In the end, you're gonna have plus 12. Be very careful. You have this minus and this minus. When you multiply them, you're gonna get positive, and it's gonna be 12. So all of that has to be done very carefully. Okay, so you have this. Then you have x equals minus 2 plus minus the square root of 16 over 2. And basically, all we have to do next is calculate the square root of 16, which is 4 or minus 4. But I don't have to write them in here, right? Because I have already these two signs in there. So there is no use in writing again plus and minus over here. So we have this. And then remember one of the solutions, the first solution goes with the plus. The second solution goes with the minus, and you can reduce even a little more. Minus 2 plus 4, that's 2 over 2, that's 1. And the other will be minus 6 over 2, that's going to be minus 3. And there you are, okay? These are your two solutions for this particular equation, and you're done. This is the end. Okay, let's see another example. Well, I have to continue. I don't know when this guy is going to be quiet, so I apologize for the noise, guys. Okay, so now we have this form, this equation. It's already in standard form, okay? So we can now just go ahead and identify A, B, and C. A is gonna be 2, B is gonna be plus 3, and C will be minus 4. And remember, this is basically the difficult part. Well, in my opinion, the rest is just a standard substitution. Okay, you have this equation, and then you just substitute. Okay, so this is a substitution, guys, and the rest is just basically reducing the complexity of this expression. Let's see how that goes. All of these will be um, that's gonna be 16 times 2. That's gonna be 32. I hope I'm not making any mistake. No, over 4. Then this is gonna be equal to all of this. Okay. And since you cannot calculate the square root of 41 because it's not exact, you're gonna keep it this way. Remember, keep it this way and just write the final solutions as the following. One solution goes with the plus. Okay, this is a perfectly good solution. You don't have to calculate or approximate this number to decimals. Keep it this way. It's a much better idea. Well, if you want to also give the approximation in decimals of all of this, that's nice. That's cool. But also try to keep this number in there. And the other solution will be this. Okay, so that's it, guys. This is our solution. These are our two solutions to this particular equation. Let's see a final example. Okay, in this last one, guys, we have this equation. Again, let's put it quickly in standard form. There you have it. Identify the coefficients. A will be 1, B will be 6, and C will be 10. And then proceed to write the solutions, well, to substitute these coefficients in the quadratic formula. So I'm just gonna do it directly now. It's gonna look like this. Okay, and finally just simplify all of these right expression. We're gonna have the following, and you're gonna notice that we're gonna stumble upon a little problem, which is this. Look, this number inside the radical sign is gonna be negative. You see? So basically, and as you may know by now, we cannot calculate the square root of a negative number. And what does that mean? What is my conclusion? What is a proper answer for this question? Okay, this is basically a question I'm trying to answer. For what numbers x do we have that x squared equals minus 6x minus 10? For what numbers x? And my conclusion, if given the fact that I have stumbled upon this little thing in here, my conclusion is that there are no solutions, as we know by now. There are no solutions to this particular equation because of this little problem. We cannot calculate the square root of negative numbers. So there are no solutions, or the solution set is empty. Also written in this way, remember. Okay, guys. Now, well, that's basically it. I'm gonna give you some comments in the class live, but that's about it. That's how you manage this formula. That's where it comes from, and that's what it means when we have these types of solutions. Okay, when you have radicals that have negative numbers inside, like so. There are no solutions in these cases. Okay, guys, so that's pretty much it. And now let's get to work once again in the portfolio and the PIA. Thank you.